Hello everyone. Today we're going to take a look at a two-way table. A two-way table is a table that we use to set up and take a look at the distribution for two categorical variables. One of the most common categorical variables that we use and measure is the sex of a person. So here's an example where they have taken at a liberal arts college, they've taken a look at the graduate students defined by their sex and field of study. So this is one variable that we have right here. This variable is the field of study. If you think about on a survey, this question would be like, what is your major? The answer to that question is not a number. Remember, that is not a quantitative variable. I don't say my major is 7. I say my major is English or foreign language, history, philosophy, political science. The other question is the second variable. This is sex. So what is your sex would be the question, male or female. So they would have those are the two sets of variables. So keeping that in mind as you look at this is that we have two categorical variables. Now, the part that people always struggle with is once I've asked those questions, I do get some quantitative data from it. I have found out that in this college there's 136 female English majors and there's 89 male English majors. Foreign language, history, philosophy, political science, we have all of those things broken down similarly by asking whether you're male or female and what is your major. What we're going to take a look at is finding two things with these. The first is going to be finding a marginal distribution. And really all we are doing with a marginal distribution is kind of putting together a totals column. So how many students are there that are male and female? And then we are going to use that to kind of convert that into a percent of people that have that. So let me move this really quick. We call it a marginal distribution literally because of where this is. It's going to end up over here in the margin. So first of all I'm doing with this is putting these numbers together. So I'm just going to take a minute and add these things together, like 136 plus 89. So I know there's 225 students total that are English majors. I'm going to do that for all of those, as well as add together and figure out how many female students and how many male students there are. All right, so now I've gone through and I've added all of these things together, and then I double checked by taking a look at how many female and male students. That's my total number of students. When I add those together, I got 529. I also added up all of the individual majors and got 529. So that's our first step. Now we're going to turn this into a marginal distribution. And what we are going to be measuring over here is basically the percentage of students, of all students that are English majors. In order to do that, remember when we are finding the percentage, we are going to say how many English majors are there divided by how many students are there. And we're going to do that for each of these. How many foreign language out of number of students, how many history out of the number of students. I'm going to go through and do this for all of these things. And I'd like to see these as a percentage. So I'm really just going to divide 225 divided by 529. I get 0.42. I'm going to round it up because it's 0.425. I'm going to round it up to 43%. And I'm going to do that for all of these. I have 16%. And I'm going to pause it while I round all of them. All right, so now I have my marginal distribution. I know that 43% of my students are English students and 12% are philosophy students. The interesting thing is that all of these things, and it should make sense, I suppose it's not that interesting, add up to 100%, but you might get a different number that we sometimes refer to as the rounding error. It may be that it's close to 100%, but not exactly. Again, just because of the way that things get rounded, you might end up at 101 or at 99, again, because of the round error. So that's our marginal distribution. There's also another distribution that we can figure out, that is our conditional distribution. So a conditional distribution, instead of saying how many students or what percent of students are English majors, I might ask what percent of female students are English majors. So in that sense, I'm really only asking for, well, 136 out of 271. What percent of foreign language students or female students are foreign language? And you'll notice, again, how many foreign language students do I have out of how many female students? If I asked what percent of male students are history majors, I've got a different set of numbers. So that's what I'm going to do next, and figure out the conditional distributions, just like I did over here, by putting it into a percentage. So it'll just be crunching all of these numbers. All right, so now I have my conditional variables kind of laid out. And what's interesting to note is being able to compare that when I look at women, half of the women are English majors, whereas only 1/3 of the men are English majors. So you can see it break down by the condition. We could also do conditional variables the other way and say what percent of English majors are female. That's a different condition. Basically, I would say, well, what percent of English majors? So how many English majors do I have? 225. What percent are female? Now I have something like this. 100. Oh, that's a bad color. Let's go with green. 136 out of 225. I end up with 60% of English majors are female. So what I want you to focus on is when you say something like this, what percent of English majors are female. Here's the key. When I put this, the of English majors, that's the total group. I'm looking at out of all the English majors, so that number goes down in the denominator of English majors. And then are female, I end up with female here. And this is where it gets kind of tricky. I'm specifically only counting female English majors. It's not really said, but because of the way we use our language, but I could say what percent of English majors are female English majors. You know, I couldn't ask the question what percent of English majors are female philosophy majors. That should be 0. I mean, you could have double majors, but for this example, but that's usually kind of some of the keywords that you look for, is the group that you're finding it of is the denominator, and then what you're looking for ends up being the numerator. So that's a conditional distribution, and keep in mind it works both ways. Again, I could ask what percent of philosophy majors are male, and in that case I would be looking at, well, I have 54 philosophy majors, 54 male and 64 total. So 54 out of 64, you'll notice there's a huge group. 84% of my philosophy majors are male as opposed to female. So that's how a two-way table works. It starts by being able to put together your marginal distribution, which sometimes isn't all that exciting. A lot of times it's just you're taking these totals and then figuring out the percentages. There's your marginal. Conditional, you are asking a question specifically about male or female or about a specific class. You could ask what percent of male students are poli-sci students, and then you're doing the conditional distribution based on a percentage.